Let's jump right in. The easiest, quickest way to get going is just visit scratch.mit.edu and click on Create. No account needed. Here is your workspace. We have our code menu on the left. These are our building blocks that we are going to pull from to create our programs. This is our script editor. That's where we're going to place all of those blocks. Over here is our stage. Here we can preview our program and test our code. Down below is where we see our sprites. Sprites are the characters and props that you can control in your program. The first thing we're going to do is actually delete our sprite. You have a little X right here to get rid of our cat, and I'm going to show you how you load new sprites. Click on this little cat with a little plus icon over here on the bottom right. And then you will get an entire library of sprites you can use. I am steering you towards llama because that's what I'm using, but you can absolutely choose anything that you want for what we're about to get into. The sprites are listed in alphabetical order. There's also a search bar on the top left so that you can find the things you want, as well as these categories across the top. Now you will see your sprite on your stage. All of our sprites are on a coordinate plane. The line that goes up and down is the y-axis, and the line that goes left to right is the x-axis. Every position that your sprite takes has a number value. So right now my llama is in the very center of everything where those two lines intersect. So his coordinate position is 0, 0. Now if my llama moves up my y-axis, his y value will go up in the positive direction. If he moves down the y-axis, he will be going below 0, so I will have a negative number. Similarly with my x-axis, if I move to the left, negative number. If I move to the right, positive number. Okay, so check out llama now. Count the number of boxes that he has moved to the right. 5. That means his x-coordinate now equals 5. Then count how many boxes down he has moved on the y-axis, and you should get 4. But remember, he moved below the intersection, which is 0, so his y-axis now equals negative 4. We would say that llama's position is x equals 5 and y equals negative 4. You can see exactly which coordinate he is currently placed at by looking at the numbers right below the stage. There are even helpful little arrows to remind you that the x-axis moves left and right and the y-axis moves up and down. Definitely take a moment to do that. Move your llama around and see how those numbers change. Now take a look at your code menu. These numbers are also changing when you move your llama around. Try that out. It's actually updating to his current location. You can also click into these little boxes and change the numbers manually. You can put in really precise coordinates if you want, but the easiest thing really is to place the sprite, then pull out the code. This will make more sense here in a second. Also know that sprites can rotate. This point and direction command will let him spin around, but we have to pay attention to their rotation style. If you want llama to face the left or the right without flipping over onto his head, you choose the left-right rotation style. The next option in the drop-down menu, don't rotate, means just that. Llama won't turn at all, no matter what kind of code is placed on him. The last option, all around, will let him rotate a full 360 degrees. We'll revisit this in a minute, and I promise it will make sense. Okay, now we are ready to write some code. Every script must start with an event to trigger it. Notice you have a whole events category here on the left-hand side. And notice how they are all color-coded the same. Go ahead and drag out this WinFlag clicked event and just place it into your script editor. This means that when you click the green flag icon above the stage, it will tell your computer to start following the list of directions in that script. So basically, this event begins a new script. Go ahead and drag your llama to the bottom left corner. We are giving him a start position right here. Remember, your motion code will update with the coordinates of the spot where I placed llama. So I placed him first, and now I've got to go grab the code that tells my program, hey, this is where I want my llama to start when the flag is clicked. So now go to your motion code section. Those are all the blue blocks at the top. And add a go to X, Y motion block. When you drag that out, it's already going to have those coordinates in place for you. Now try it out. Drag Llama with your mouse to a new spot and then click the flag, and he should return to the coordinates that you programmed. No matter where you move him, once you click the flag, the computer is putting him back to the coordinates that you programmed. Now move Llama to the bottom right corner. Remember that those coordinates now will update for you. Go back to your motion code list, and this time I want you to add a glide to XY motion block. The preset amount of time will be 1 second, and like I said, the coordinates will already be loaded for you. So let's read this program. I have when my flag is clicked, go to these coordinates, then glide for 1 second to these new coordinates. Click the flag and Llama should move from left to right. So here I am just clicking it repeatedly, and each time he goes back to the left side and then glides to the right. Now let's make Llama turn to face the other direction. In order to do that, I have to pay attention to my rotation style. So I talked a little bit about that at the beginning. I don't want him to spin over on top of his head. I just want him to turn around so he can walk the other direction. So I need to add a set rotation style motion block, and I need to make sure to choose left-right from my options on the drop-down menu. Then add a point and direction motion block and type -90 to face him in the other direction. Then play your program twice. What do you notice? So we programmed Llama to make a change in the direction he faces, but we forgot to tell the computer what direction Llama should face in the beginning of the program. This is a really common mistake that early coders make. You must always program how you want your sprites to start. If you fail to do that, your program actually will probably run correctly that first time. It'll look okay, but then when you play it the second time, you will notice the problem. So I have him pointing -90 degrees down here. That means I need to start out +90. Make that correction and then test your program, and you'll see that this time he resets properly. So now, can you make your Llama walk back to where he started? See if you can figure out what code block to add that will bring him back over to the left side of the screen. Pause the video and try it out, and then hit play when you're ready to move on. Here's our solution. We need to first move the sprite to our new position on the left-hand side of the screen so that the coordinates will update, and then drag in your glide code. Now, your coordinates might be a little bit different than what you're seeing right here on the screen. That's totally fine. I maybe just clicked my Llama into a slightly different position than you did, but as long as your program looks like mine, where he's walking to the right, turning around to face the other side, and walking back to the left, then you are in good shape. So now I want you to actually pull off those last 4 code blocks. Hover them over your code menu and release them. This will cause them to delete. So we're taking off those last 4 and dumping them. You also could just pull off those code blocks and place them to the side in your script editor. The code blocks you pulled off would not affect your program because they're not attached to an event block anymore. Without an event block, the code doesn't do anything. So keep that in mind. You've got to have an event block. So you could have some extra pieces of code that you're playing with or working on, just disconnecting from events, and keep them in your script editor if you needed to preserve them. But for right now, just get rid of those. We're going to try something a little different. Your code now should look like this. So this script just says when the flag is clicked, point 90 degrees, and start in this position. I want you now to add a change X by and a change Y by motion block and change both of those numbers to 100. The idea here is we're telling the sprite to move right on the X-axis by 100 and then up on the Y-axis by 100. So this is a little bit different way to make our sprites move around that I want you to be familiar with. Click your flag and watch how Llama pops up in a new spot. We don't see him move right on the X-axis and then up on the Y-axis. Click your flag again and Llama won't move at all. He just seems stuck in one spot. What do you think is going on here? With the glide motion block that we used, Llama was programmed to spend 1 second moving to the new set of coordinates, which means we could see it happen. With the code we have now, there are no timing instructions for the computer to follow. This means the computer moves so quickly through that list of directions that we don't even see anything happening. It's basically instantaneous. To fix this, go to your list of control commands in your menu and find the wait seconds block. The waits will already have a 1 in the box, which means the computer will wait 1 second before moving to the next code block on the list. But you can change the number to be anything you want, even less than 1 second. You can actually put in a decimal. But for what we're doing right now, you just want to add a wait right before we change the x coordinate and right before we change the y coordinate. Now he's going to visibly move forward and then up. Now, can you make him turn and move back to the left like this? So pause the video, think about what we've already gone over, and see if you can program that llama to turn to face the other direction and move to the left side. So to get llama to switch directions, we have to point him in the other direction, which is -90, and then we can move him left on the x-axis. To get exactly where we were before, we can just put in -100. Now you could have also used the move code we already played with or a glide code, but this is how you would do it just by changing the coordinate. You can actually preview a command by clicking it on the code menu. Try clicking this one, the go to random position, a few times, and you'll notice that your llama will just pop all around on your screen. You can click on other commands as well to get a little bit of a preview of what they do. However, this is not a part of your program unless you actually drag it into the script editor and add it to other code, or at least to an event. It's really important, as I think we discovered through this activity, to always give your sprite a start position in your code. You can't have him move somewhere unless he knows where to start. Now I have a little challenge for you. I want you to add on to the program so that your llama moves down to the bottom left of the screen, turns to face the right, then glides up to the top right corner of the screen. I'll play it for you one more time. So pause the video, try that out, and when you're ready for the solution, hit play. Now there's more than one way you could have approached this. That's one of the really cool things about coding, is that there's many different paths. So don't stress if what you came up with looks different than my code here. If you got the right result, if your llama did what he's supposed to do, then you did it. You solved the challenge. The way I did it was to add a wait. I changed my y coordinate by -100. I waited again. I pointed in the other direction, 90. Remember, I was -90 up here, so now to flip around, I need to be +90. I waited 1 second, and then I glided to my new coordinate up in the right-hand corner. All right, you've done it. You wrote a program. I know it's very simple, but you wrote a script to make this character move around your screen. Now that you've done that, I think you're ready for something a little bit more interesting. Go up to your top menu bar, click on File, and choose New to start a brand new program. We are going to delete the cat once again, and we're going to make a little bit more of an animation, something that's a little bit more interesting. Okay, so we're going to make a little animation of a girl hitting a baseball. To do that, we're going to learn about adding backdrops, changing costumes, and adding sounds. The first thing we're going to do is add that baseball backdrop. If you look on the very bottom right-hand corner of your screen, you have this little landscape icon. If you click on that, it's going to bring up your backdrop library. Very similar process to adding a sprite. We want to choose baseball 1 from our options. Remember, you can always type that into the search bar if you need to. And then we need to click on that cat plus icon to bring up our sprite library. This time I have 2 sprites. I need to get the baseball and the batter, and then I need to arrange them like you see here. Select the baseball's thumbnail to choose its script editor. So we build code on the sprites separately from one another, and we're going to start with our baseball. We're going to start that new script with a WinFlag clicked event, so that's my trigger, remember, that's telling my computer when to start the list of commands. And then I'm going to add the code that you see here. Let me explain why. First, we need a show command from your list of looks blocks. We need to make sure to show the baseball now because later we will want to hide him when he gets hit by the bat and goes off the screen. If we don't have a show at the beginning, our program won't restart properly. The sprite will just stay hidden. We can use the set size looks block to shrink the size of the baseball just to make it a little more proportional because right now it's really big. So you can just type in a 50 and that's basically shrinking the baseball to 50% of its original size. We also need to set our starting coordinates. We need to know where should the baseball begin in the program. Now move the ball in front of your batter. So we had a start position of it over on the left-hand side and it needs to move towards the batter. So let's go ahead and put the baseball where it needs to go. Now add a glide to XY motion block. Remember the coordinates updated when we moved that ball on the screen. So now my program is telling me that when I click the flag, I'm going to make the baseball visible, I'm going to shrink the size to half, I'm going to start on the left side of the screen, and then I'm going to glide over to these new coordinates right in front of the bat. Don't worry if your coordinates are a little different from mine. They most likely are a little bit different because we may have positioned things slightly differently on our screens. Test your program. The ball should start on the left and glide towards your batter. If your ball isn't moving like this, then take a look at your code. Maybe rewind the video a little bit to double check it. One thing to pay attention to is that you do indeed have different coordinates here. If you have the same coordinates, then you have not told the sprite to actually move. So make sure there are separate starting coordinates and ending coordinates. Now we're going to move the ball to the far upper left like it has been hit out into the distance, like she's just hit a home run. Add your glide motion block and a hide looks block. We want the ball to disappear because we're creating the illusion that it's been hit off into the distance. Now the ball should move towards the batter and then turn back the other way and disappear off the screen. Notice that when the ball comes close to the batter, I did leave a little bit of room there because we need room for her to swing the bat. So that's our next step. We are going to click on the little thumbnail of the batter and we're going to switch to her script editor to give her directions about what she is supposed to do now. So you automatically will be on the Code tab, but I want you to click on the Costumes tab, which is right next to it here, and take a look at what we have. All of these different costumes show her in different positions. So when we talk about Sprite Costumes, you probably were thinking of maybe different outfits. That can be the case, but mostly our Sprite Costumes are ways to give our sprites movement. They're usually a different costume is a sprite in a different position. So then after you have checked out her costumes, click back on that Code tab where we just were to get back to her script editor. Start a new script with a WinFlag clicked event, and then add 4 switch costume commands from your list of looks blocks. Click the arrow on each one and select each of her costumes, starting with batter A, then B, then C, and then D. So we're telling her basically to switch through each of those motions of swinging a bat. Test your program, and you're going to discover that we put in 4 costume changes, but she jumped straight to her last costume, batter D. Why is that? Remember when we had to put in some timing when we used the change X and change Y motion code blocks with the llama earlier? This is the same thing. Right now, we are telling the computer to change to each costume, but without any weights, it happens too quickly for us to see. It's happening in a microsecond. So we're just seeing it end on the last costume change we programmed. To fix it, we need to add 4 weights. And let's actually adjust the timing on these. So put in your 4 weights in the appropriate spots. The very first weight needs to be 0.5, and that's to time her movement with the ball. And you could always adjust this number if you need to once you test your program, but we want the timing to work out that she's moving when the ball is getting close to her. Then these other weights need to be something really small, like 0.2, because this is a fast motion and it needs to look like it would in real life. Then let's add a sound for when the bat hits the ball. Click on the Sounds tab above your code menu. It's right next to that Costumes tab that we looked at earlier. And then you want to click on this little sound icon on the bottom left. This brings up your sound library. You can click the little purple arrows to preview little sounds. It feels like our other libraries we've already been in. There's a search bar, there's categories you can sort by. But the important thing here is that we have to choose a sound from our sound library before it is available to use in our code. The sound I thought worked the best is actually called tennis hit. You can scroll through because it's an alphabetical list, or you can type it in the search bar. But go ahead and choose tennis hit, or if you want something else, if you want a trombone sound or something a little goofy, you can choose that. Now click back on the Code tab and then scroll down to your sound code section in your code menu. There are two ways to get your sound to start. This first one, play sound until done, means that the entire sound will finish before the program goes on to the next line of code. So if you wanted your sprite to be like dancing to a song, you would not want to choose this one, because what would happen is the whole song would play and then the sprite would start doing those motions of dancing. In that case, you would want start sound. This means the sound will keep playing while the program moves on to the next line of code. So for this program, we want to use that start sound block. And we're going to place it after the batter C costume. That timing should work pretty well so that we hear the sound when we see the baseball making contact with the bat. But I don't want to hold up anything else in my program. I want it to move right ahead to that last costume change and not wait for the sound to finish. How'd we do? Hopefully everything's running smoothly, but if not, make some adjustments. Maybe you need slightly different timing on your program than what I had. Take a look here at all of the code in one place. This is what you should have for your baseball. Here's everything for the batter. Quick note that I want to make clear is we chose the baseball backdrop for our batter, but we didn't actually place any code with it. If we had wanted the backdrop to change during our program, we would have needed to put the backdrops into our code. Here's an example of what it would be like if we had wanted to start in a baseball field and then we wanted to switch to a basketball court. I would have to actually set that starting backdrop and then put in when I wanted to change. So here is your assignment. I would like you to add on to this program. I want the batter to receive a new pitch, and she swings, and this time she misses the ball and it disappears behind her. Pause the video, get to work on that. When you're ready, hit play and I'll talk about the solution. So for my baseball, I just added a wait of 1 second to give it a moment, and then I gave it a starting coordinate. It's actually the same as my original starting coordinate so that it feels like it's coming from the same place, like it's being pitched again. Then I need to show the ball, and then I have it glide to a new spot, which is going to be behind my batter, because remember, my batter misses the shot. And then I hide the ball so that it looks like it's disappeared into the distance. For my batter, I just had her move through those costume changes again, but I had to really play with the timing a little bit to make sure that everything synced up with my ball.